So the next question is the last video for chapter 12.2. It's a really intense question. It's pretty long, so take a deep breath. We can work on it together. So they want you to graph this degree 4 function. And this degree 4, which is an even leading power, right? And it's a polynomial function, and the a is positive, so hopefully you know the end behavior is what? The end behavior is going to be both sides up. It can have up to how many turns? The maximum turn is 4 minus 1, which is 3 maximum turn. So, but it doesn't mean they always have 3. It can have up to 3. So some of the things we can do, because they ask for a lot of things. They want a graph, they want a domain. Domain is easy because it's a polynomial, which means it's go on forever. So it's negative infinitive to positive infinitive, right? While the interval of the function is increasing and decreasing, that's first derivative, along with the local maximum or minimum. And then found the concavity up and down, that's second derivative. And then the inflection point is where the concavity change, right? So this I already know is going to be all real number because it's like polynomial functions. And increasing, decreasing, local extrema is first derivative, concavity and inflection point is second derivative, right? So that gives us some idea. But either way, we know this is number 5. It's a polynomial function. Polynomial function go on forever, so the domain should be negative infinitive to positive infinitive. And we can look at the graph at the end and try to double check that information. But because we're going to need the first and second derivative, so we're going to go ahead and try to find that. So we do f of x is x to the 4 minus 2x cubed. Then the first derivative would be 3x cubed. I'm sorry, what did I do? 4x cubed. 4x cubed minus 2 times 3 is 6x squared. Okay, and then we need to find those critical value. Then we need to set f prime of x equal to 0. 4x cubed minus 6x squared equal to 0. To solve for that, what can we do? We can factor. So they have 2x squared in common, right? So after we pull out 2x squared, we still have 2x minus 3 equal to 0. So if you set that each equal to 0, 2x squared equal to 0, x squared equal to 0, x equal to 0. 2x minus 3 equal to 0, 2x equal to 3, x equal to 3 half. So if you need to pause the video and catch up, please do so. So those points is going to help me to figure out increasing and decreasing, right? So let's try it. X equal to 0, x equal to 3 half or 1.5, right? Alright, so write down the interval and test some points with the first derivative to see where it's increasing and decreasing. You can pause the video and then we can check your answer. Alright, so this is negative infinitive to 0, 0 to 1.5, 1.5 to infinity. So I can test point, plug in f prime of -1, f prime of 1, and f prime of 2, which is this function, right? So 4 times -1 cubed minus 6 times -1. So your answer for that would be a negative number. The second one, your answer should also be a negative number. And the last one should be a positive number. So because f prime of x equal to negative, f prime of x equal to negative, f prime of x equal to positive, what do you think is increasing or decreasing? The function is, the first one is decreasing. Second one is also decreasing. And then the last one is increasing. So it's going to go down and down some more, but then go up. So we will have one local extremer, which is a local minimum, go down and back up, right? So if we have a local minimum at x equal to 1.5, then we can plug it back to where? Okay, the original function 1.5 to see what we get, right? So you can leave it as fraction, or you can plug it as the fraction or decimal number. Either way would be okay. I think I did the fraction one, so if I plug in the fraction one, f of 3 over 2, because sometimes that's more accurate, then I will have the original function, which is 3 over 2 to the 4th power minus 2 times 3 over 2 to the 3rd power, which will give me 81 over 16 minus 54 over 8. You can find the lowest common denominator, which would be 16, meaning this need to times 2, right? So we do that, we will have 81 over 16 minus 108 over 16. So together, that's going to be a negative 27 over 16. So the local minimum is x is 3 over 2 and y is negative 27 over 16. So a little bit lengthy, I must say. So that's the local minimum. And we already know the increasing and decreasing part, right? So we found the domain at the beginning is negative infinity to infinity. So we want to keep track with what we found. Increasing, decreasing, local extremer. So that's local extremer, and then decreasing is going to be starting from negative infinity, go all the way to 3/2 or 1.5, and the increasing part is going to starting from 3/2 to infinity, right? So it's switching from decimal to fraction, back and forth. Hopefully you don't get too confused. So that's the first part of the questions. And then it also asks for concavity. So if they want to know concave up and concave down, they're going to need to take the second derivative. So second derivative is going to be f prime of x was 4x cubed minus 6x squared, right? So that would be 12x to the second power minus 12x. So, and then we need to set it equal to 0 to find boundary point, right? Okay, so 12x squared minus 12x equal to 0. So we do the same thing, right? We factor. So pull out 12x times x minus 1 equal to 0. So set them equal to 0. 12x equal to 0 divided by 12x equal to 0. X minus 1 equal to 0, x equal to 1. So I got 2 points for the concavity to check. So let's do it here. One is x equal to 0, one is x equal to 1. And then we have starting from negative infinity to 0, 0 to 1, 1 to infinity. This time we are trying to figure out the concavity, so we need to test second derivative with negative 1. 0 to 1, I don't have a lot there, so maybe 0.5. This one may be a 2. So if you plug it into the second derivative, which you do like with this guy, 12 times the negative 1 minus 1, negative 12, negative 2, so it's a positive 24. So it's a positive number. When you plug in a second derivative, you get a positive number. It means concave up. And then when you plug in a f prime of 0.5, then you get a negative number. If you have a second derivative turn out to be negative, it means concave down. And then we plug in the very last one, and then we will have a positive number. If a second derivative come up with a positive number, it means concave up again. So it changed concavity twice, right? What does that mean? So it means when x equal to 0 and x equal to 1, both of them are inflection points. So we can say for the concavity part, the concave up, we have negative infinity to 0, also 1 to infinity. Concave down, we have 0 and 1. Inflection points, we got x equal to 0, x equal to 1. And we need to plug in where to find the y value. We need to plug into the original functions. So we plug into the original functions, which is something to the 4 minus 2 to the something cube. So plug in a 0 here. Plug in a 1 here. So the first one is just 0. The second one is going to be a 1 minus 2, right? So negative 1. So inflection points including 0, 0, and 1, negative 1. So that's not done, right? They also want a graph, so this is a really long problem, right? So we got a lot of information. Using those information, we're going to attempt to graph this. So I know this is a degree 4 because f of x is x to the 4 minus 2x cubed. And then a is positive, so the end behavior for even leading power with a positive is both sides up. The maximum turned is 4 minus 1 equal to 3, so something like that, maybe. That's the maximum, but they can have less than that. And then we know that increasing is 3.5 infinitive, decreasing is so for the decreasing part, did I write down earlier? Yeah, so the decreasing is negative infinity to 3/2, and then the local minimum is 3/2 comma negative 27/16. So on the graph it's about 1.5 and negative 1.69. Concave up, negative infinity to 0, 1 to infinity. Concave down is 0 to 1. Inflection point is going to be 0, 0, and 1, negative 1. We probably need to find the intercept, x-intercept, and y-intercept. And I have a hard time spelling today, sorry about that. X-intercept set y equal to 0, and y-intercept set x equal to 0. Alright, so if I set y equal to 0, what do I have with my function? That's my function. Give me a second, sorry about that. So it started with x to the 4 minus 2x cubed equal to 0. I can factorize, so x cubed times x minus 2 equal to 0. So x equal to 0, x equal to 2. So 0, 0, 2, 0. Y-intercept set x equal to 0. So 0 to the 4 minus 2 times 0 cubed equal to y. So y just equal to 0. So 0, 0 again. So I got a lot of information. Let's try to graph it. And if you are familiar with graphing calculator, you can also use that to help a little bit to double check your graph, because these are pretty complex. So I have a point at 0, 0. I have a point at 2, 0. So let's make it pretty far apart so I can figure this out easier. Let's say this is 1, this is 2. So it's supposed to be both sides up, and I know that I have, so these are all the information I have. I already plug in my intercepts. I know one side is going to be up here and one side is going to be up here. And I know I'm supposed to go decreasing until 1.5. So 1.5 about here. And I need a 1.5, and the other number is negative 1.69. It's about here. So I have a point here somehow. So I know from decreasing negative infinitive until here, so this point is my positive 1.5 and negative 1.69. So it's go down continuously, but concave down, like a finally phase is between 0 and 1. So even though go down continuously, concave down, so this is the local minimum. And I have an inflection point at 0, 0 and 1, negative 1. So it changed concavity here, and concave down from 0 to 1, and negative infinitive to 0 is concave up, and then from 1 to infinitive is concave up. So change to be an up again like that. So the concavity change. So from here to here is concave up. From 1 to infinitive is also concave up. But we do have inflection points. So the graph is about like that. So it gives you a little bit more details and where the graph is like changing. And it's a pretty complex process. So if you have graphing calculator, you can also use it to double check.